one of the things I've seen some of the other units. SI measurement. SI stands for System International, which is the standard unit that we use mostly in physics and chemistry. It is sort of a combination of two different measuring systems. So this is on your page 1, chapter 1, page 1. In Canada, what type of measuring system do we use? Metric measuring system. So give me an example of a length that you would measure a length in. Meters, sure. What about a long distance length? Kilometers. What about something really small? Centimeters, millimeters, perfect. But they're all picometers, sure. They're all really, really small, right? Okay, so they're all based on the meters, correct? So we convert to meters. That's great. Okay, and so we have all these prefixes for meters to tell us how they are related to 1 meter. For example, 1 kilometer. I suppose it could be RE. Did they put it RE in here? Yeah. British way of doing things. Okay. So 1 kilometer is how many meters?
1,000.
1,000, that's right. There's 1,000 meters. The word kilo is short for 1,000. Okay? So then we have a hectometer. They give you those ratios on the page there. So a hectometer is 100 meters. A decameter is 10 meters. A decimeter is 0.1 meter. A centimeter is 0.01 of a meter. And a millimeter is 0.001 of a meter. So one of the things that I could do as well, though, is I could write my big one like this, so 1 meter. And then I can write it as a ratio, because this is the way that I want to solve if I have to convert. So I'm going to write it as a ratio. 1 meter is how many millimeters? How many millimeters are in a meter? Okay, now, the correct answer is 1,000 millimeters in 1 meter, which then would work out to 0.001 meters. Okay, that's how we get to 0.001. There is 1 meter there's 1,000 millimeters in 1 meter. So if I take 1 and I divide it by 1,000, I end up with 0.001. So I don't like to use the decimals if I don't have to in my conversions. I try and use whole value units. All right, look at the top of page 2. We're getting into these already, so I'll go through this and I'll come back. Now, one other thing that you're going to find is that I do go things through fairly quickly. We will move quite rapidly through these things. If you are feeling panicked and that you feel like you're getting behind, just simply put up your hand and say, hey, can we go back through that again? All right? Okay? Because I don't know your abilities. Outside of Amber's the only one I've taught so far. The rest of you, I don't know where you're at. So when I move through things, sometimes I expect you to know certain things, and maybe you don't. So then you just got to say, hey, we didn't do that, or I don't remember that. Fair enough? Okay. When we measure something small, we use a device called a caliper. All right? So has everybody seen a caliper before? It's a sliding device. Most of you, if you're in shop or if you've done shop, they'll have calipers in there. But it's a sliding device, and it gives you an example of just what the scale looks like on the page there. But they're sometimes hard to read. So I'm going to go through it today, and I'm going to repeat this again tomorrow, because this might be one thing that will confuse you. So take a look at the scale then. The big numbers on that scale represent whole number centimeters. So the first thing that you do is on the bottom, you see that little scale with the 0 on the bottom? You want to find out where the 0 is located in terms of the big whole numbers. So where is it located? Between which two whole numbers is it located between? 2 and 3. 2 and 3. That means that the first number then is a whole number 2. So the measurement is 2 point something centimeters. So that's what we're going to get at. Okay? Now, the next measurement is 1/10 of that centimeter, because each of those ticks is 1/10. So where's that 0 located? 0.2 something, right? So you would say it's greater than 0.2 but less than 0.3. Would you agree to that? Okay, so I'm going to add that into there. Now, I can measure this to the nearest hundredth using that little scale again. Now this is where it gets interesting. What you want to do is you want to find the value or the tick on that little scale that is exactly matched up with one above it. So it's exactly measured or lined up with the one above. So is the 0 lined up with the one above?
No.
No. How about the first tick?
No.
No. Second tick?
No.
How about the third tick?
Yes.
Yeah, I would say it's lined up exactly above, right? That means then that I have 3 1/100ths. So what is the actual measurement using that scale?
2.23.
That's exactly right, Wyatt. 2.23. Good. Okay? How are we doing? All right. Now they only give you like 3 or 4 examples in this whole section on how to use these. So I wouldn't fret if it's not coming to you right away, but you will get a couple chances. You can see on page 3 there's a couple there, and then when we get into Imperial they throw a couple at you, but for right now that's all I need. Okay. Now the important thing for me to you, and I know that you can do this because you did it last year, and that's, can we convert just simple linear measurements? So let's look at our example question. 2 students in a biology class measure the length of an insect specimen. Kelly determines the length to be 8 millimeters. Caleb states that the length is 0.008 meters. What referent could be used to estimate the length of the specimen? So a referent is something that's similar in size. So what would be similar in size to, let's say, 8 millimeters? Something that you know, something on you, who knows?
Fingernail.
Fingernail. That's right. Maybe 8 millimeters, maybe. Right? That's a possibility. That's what we refer to as a referent. Okay, just something that you can measure that would be similar. Like this guy, it's about, I don't know, 4 or 5 inches, right? So if I had some measure, I could say, well, my marker. You know, a pen might be 3 inches. That would be a referent. Okay? What unit measurement of all possible units is the most appropriate for measuring this length? Okay, if you're measuring something small, what's the most likely measurement that you, well, what do you measure most things in according to the rulers that you actually possess? Centimeters. That's right. But they're usually broken down into little ticks that are actually millimeters, right? And so that's usually what we use for some small units. Okay? So now they want you to compare Caleb's measurements. All right, so this is the first thing that I want you to take down. I want to put both of these measurements into the same units. Okay? Now, I could convert meters to millimeters, and I could convert millimeters to meters, but I'm going to just practice. I want to practice. I want to show you how I would set this up. Yeah, go ahead.
Can we write in these books if we plan on bringing money for them? Or
What?
just wait until...
No, right. You're ready to go. You're in this class, right in those books. Okay? Okay, so we're going to practice here. I'm going to change 8 millimeters into centimeters, and I'm going to change 0.008 meters also into centimeters to see what they look like. Okay? So I'm going to show you how I would set this up. Now, I do this in physics. I know it's done in chemistry. I want to set this up the same way all the time. Now, I know that if I took 8 and I divided by 10, I would get the number of centimeters. I know that. But what happens if I have to change kilometers an hour per hour into meters per second? I've got to do multiple conversions. So that's a little bit more difficult to do. So I'm going to set it up the same way every single time. So here's what I want to do. I'm going to set up a ratio. Now what is it I want to change it to? Centimeters. And what am I changing it from? Millimeters. Now what I want to know, do I know what the ratio of centimeters to millimeters is? What is it?
110.
1 to?
10.
So 1 centimeter has 10 millimeters in it? Great. So I go 1 to 10. Okay, so far? Equals. I'm going to write this down. All right? Now, what does this line mean? It means, yeah, that's exactly correct. It means divide, doesn't it? So, because I have the millimeters on top and I divide by the millimeters on the bottom, they actually cancel out. So what units am I left with then? Centimeters. Now, I multiply across the top and I divide by whatever's on the bottom. So what's 8 times 1? 8. So I really don't need to do that, do I? But I do need to do 8 divided by 10. And what's 8 divided by 10? 0.8. That's right. 0.8 centimeters. Okay? I'm going to give you about 20 seconds, and I want you to set up how I change my meters into centimeters. The same idea that I had above. Okay? Okay, what do I want to change it to? Centimeters. And what am I changing it from? Meters. So what's that ratio there then?
100.
Chucks?
100 centimeters over 1 meter.
100 centimeters over 1 meter. Perfect. Meters cancels with meters. Centimeters right there. 0.008 times 100. What's 0.008 times 100? What do you have? 0.8. What did we find out about the two measurements these two did in their question? Did they get the same measurement? Yeah, they did. Perfect. Okay. Okay so far? All right. Just for fun, it's not in your book. We're going to do a little bit of practice here for a second. Let's go. Okay, I'm going to make this a little bit. Oh no, I'll start with this. Okay, I want to change 28 kilometers into my SI unit for length, which is meters. So I want to change meters or kilometers into meters. So let's set up the ratio. What do I want goes on the top? Which measurement? Which units do I have on top?
Meters.
Meters. And which measurements do I have on the bottom?
Kilometers.
Kilometers. Okay. And what's the ratio? 1,000 over 1. That cancels. That cancels. And what does that leave me with? Meters. That's right. And how many meters is that? 28,000. Very good. Awesome. Okay. Now, Any questions so far? So far, we remember this from last year? Huh? Great. That's the hard part about this too. You haven't taken math since last June, most of you. So catching up on math is also going to be a bit of an issue. All right, I want you to flip to page 5 for a second, please. So what I basically do is I'm going to give you a lesson in a bit today, and then you're going to finish off the first lesson, and then tomorrow I start at the last half of the lesson 1.2, and I go on to 1.3. So what it does is it keeps us just moving at a nice pace. All right, so I'm just going to quickly introduce imperial measurement. What are some of the things that we use imperial measurement, or what are the types of units that we use for imperial measurement?
Foot inches.
Foot, inches,
Yards.
yards, miles. Awesome. Where do we see them primarily?
Height.
Height, yeah.
Hour.
Sorry?
Miles per hour.
Miles per hour. Do we use miles per hour?
No.
Not with the U.S. would, right? But that's right. That's right. Miles per hour would be one. Okay. What about in Canada? Because there is one area that we do use imperial measurement more than we do probably metric.
Height.
Height?
Like, no, I know what it is. I'm like 2x4s.
Ah.
Construction.
Lumber. Lumber. Correct?
Yeah.
Right? Because it's like Lily said, 2x4s, 2 inches by 4 inches. Okay? So that is one area, the construction area industry, that's one area where we do use a lot of imperial. Cubic yards, cubic feet of fill or cement or whatever it is that we're on. Okay? So it is important that we do learn it. However, some of those measurements are being converted. We can buy sets of wrenches that have millimeters on them now, right? And lumber does come in different sizes that is metric, okay? But we want to do some imperial. So what I want you to do right now is just have a gaze at page 5 there. And I'm just going to do some simple conversions so that you have them beside you, all right? There are 12 inches in 1 foot. Okay? There are 3 feet in 1 yard. Okay? There are, I'm going to peek at this, 1,760 yards in 1 mile. Okay so far? All right. So these are the standard kind of conversions that we're going to use as we go through section 1.2 and we work through it. Now there will be, the next section will be to convert from metric to imperial and imperial to metric. All right. And that is 1 inch is 2.54 centimeters. That's the biggie right there. But we don't need that. Certainly don't need that today or probably even tomorrow. Look at page 6. I'm going to go through one more example, and then you've got the rest of the day to go through the first lesson. Mary and Lang need to determine the area of a room they wish to paint. The room is rectangular with 1 window and 1 door. Mary measures the perimeter of the room to be 52 feet and the window to be 1.5 yards by 2 yards. Lang measures the height of the room to be 96 inches and the door to be 78 inches by 42 inches. Only the walls are to be painted. What is the area to be painted and measured in square feet? Okay. So, first things first. They say Mary measures the perimeter of the room to be 52 feet. So, what is perimeter?
Area around.
Yeah, it's the distance around the room, right? So that's the perimeter. That's 52 feet. Okay, so that's 4 walls on it. Now, we don't want to paint the window. We don't want to paint the door, do we?
Mm-hmm.
So let's find out how much area there is there, because we're going to talk about area. So the window. what are the dimensions of the window?
1.5 yards by 2 yards.
1.5 yards by 2 yards. So what I want to do is let's work as much as we can in feet. Okay? So what's the conversion that we're going to use? I want to change yards to feet. What's the ratio? How many feet in a yard? 3. So I'm going to take 3 and I'm going to times it by 1.5. And what does that work out to? Go ahead, Brooklyn. You had it. 4.5 feet. Okay? And 2 yards, same ratio, 3 feet by 1 yard. So that's 6 feet. So what's the area of that window then? How do I find the area?
Length times width.
Length times width. So 4.5 by 6. What's 4 times 6?
That.
4 times 6.
24.
24. Now you can take half of 6, which is what? And add it to 24. 27 feet. So it's 4.5 times 6 should be 27 feet squared. So there's the area of your window. Okay? Area of the door now. So what are the dimensions of the door?
36 inches by 78 by 42. No.
78 inches by 42 inches, right? 78 inches and 42 inches. Okay? So now, again, I want to work in feet. So what's my ratio? 1 foot has how many inches? 12 inches. And 1 foot has 12 inches. Okay? So take 78 and divide it by 12, and what do I get? 6.5. Very good. 6.5 feet. And then I take 42 divided by 12.
3.5 feet.
Excellent. 3.5 feet. Now, to get the area of the door, I have 6.5 times 3.5. You have calculators, you can punch that one in. It's a little harder to do.
6.5 times 3.5?
Yeah.
2275? Well, that's not 75.
Perfect, thank you. Okay. So far, I have the area of the door, I have the area of the window. Now I need to find the area of the walls. Okay? So I have 52 feet is the perimeter, right? And the walls are 8 feet high. So if I take 52 and I times it by 8, the area of the walls is the perimeter of the room times the height of the room. Gives me 416 square feet. 416 feet squared. So how much room am I going to have to paint? How would I find it?
Subtract the area of the window door from the area of the walls to subtract area of the walls, subtract area of the window and door.
Beautiful. Okay. 416 minus 27 minus 22.75, and that works out to 66.25 square feet. There you have it. And we're on. Okay? So basically all I wanted you to take from that little bit today, you don't have to get into 1.2 today. All I wanted to do is introduce it to you. We will go back through this example a bit tomorrow, but I want you to know how to convert and how the process I think is the easiest way to convert, and that's using these ratios. You see my ratios here? These guys? That to me is the most consistent way in which you can convert units. Okay? You have the rest of today to finish up 1.1. Start it and finish 1.1. All right?
That's a practice thing.
Yeah, the practice. Right.
Do we have to do the extended and the city connections?
No, you go as far as you need to.